Before, in our prior video, we were talking about where is x squared minus 5x plus 6. We said, where is this guy less than 0? And we looked at the graph of x squared minus 5x plus 6. And we recognized that when we factor this into x minus 3 times x minus 3 times x minus 2, and set it equal to 0, we found zeros at 3 and 2. So we know at 2 and 3, this graph will cross the x-axis, and he will continue on in such a manner. And we defined the graph being positive, being above the x-axis, and the graph being negative below the x-axis. So let us discuss a more analytical, a slightly more analytical approach. Is that correct? I hope that's correct in saying. Let's discuss a more analytical approach. Let's discuss a way to compute this analytically. So how about that? Let's discuss a way to compute this analytically. So if we think about this, when we have our x minus 3 and our x minus 2, we are always multiplying. We're always multiplying these two values. So we're multiplying these two values, and when we multiply them, we recognize that the signs are going to change. We recognize the curve will be positive over here. We'll do a different color. It'll be positive over here. It'll be negative down here. It's going to be positive again. So we recognize that it changes signs 3 places. So let's think about how we can recognize where this graph changes signs. So let's pick a value over here. Let's pick a value like 0. Let us pick a value like 0, and we're going to plug it in and see what happens. When I plug in 0, I'm going to have negative 3 times a negative 2, and that's going to give me a positive 6. So we recognize when I plug in a value anywhere to the left of 2, my graph is going to be positive. And that's not negative, it's going to be positive because you multiply 2 negatives together and you get a positive. Let's pick a value between 2 and 3. Let's go ahead and pick a value like 2.5. So plugging in 2.5, so we plugged in 0 here, we plugged in 0 here. Now we're going to plug in 2.5, and let's see what happens with 2.5. We're going to have 2.5 minus 3 and 2.5 minus 2. 2.5 minus 3 is negative 0.5. 2.5 minus 2 is positive 0.5. 0.5 times negative 0.5 gives you a value of negative 0.25. So we have a positive times a negative when we get a negative. And notice here, we got a negative, which is what we expect our curve to be. So everywhere between 2 and 3, our graph is going to be negative. So let's go ahead here and analyze, and this is supposed to be a set of quotes. Let us analyze the value to the right of 3. Let's look at 4. When I plug in 4, I'll do 4 up here. And when I look at 4, I'm going to plug in 4 minus 3 times 4 minus 2. 4 minus 3 is positive 1, and 4 minus 2 is positive 2. Positive 1 times positive 2 gives me a value of positive 2. It's positive 2. Oops, I lost my cursor there. I got positive 2. And notice, to the right of 3, we are always positive. So there is an operation we're going to learn, or a special way to analyze this, and it's going to be called a sign analysis. A sign analysis can be used to identify where our curve is going to be above the x-axis or below the x-axis. But the first thing we have to have with a sign analysis are our critical points. And we're going to learn the critical points specifically of a polynomial are the zeros. The zeros are the critical points of a polynomial. And notice here we have our zeros. We have our 0 at 2 and we have our 0 at 3. So the first thing we're going to do with a sign analysis is that we are going to line that up. We're going to line a number line with our critical points in an ascending order. So my first critical point is going to be a value of 2, and my next critical point is going to be a value of 3. So these are my critical points. The next thing I'm going to do is that I'm going to line the factors corresponding to my critical points vertically. So my first factor is going to be a value of x minus 3. That's my first factor that corresponds to my critical point. And then my next factor is going to be x minus 2. So I'm trying to show the resemblance and the similarities between my curve, my graph, and my number line. So I recognize that I can change signs in 1, 2, 3 different intervals. We can change signs in 1, 2, 3 different intervals. And we recognize that x minus 3 and x minus 2 will have the same sign in all 3 of these different intervals. So let's analyze x minus 3. X minus 3 has a critical point of 3. If I pick a value to the right, like 4, x minus 3, plugging that in, I'm going to have 4 minus 3. That's going to be a positive value. I plugged in 4 and I got 4 minus 3. That's positive 1. If I pick a value to the left, no matter where it is, it could be here at 2.5, it could be here at 0, it doesn't matter where it is, to the left of 3, x minus 3 was always going to be a negative value. It's always going to be a negative value. So it does not matter where we are. Notice here, our x minus 3 was negative when we plugged in 0. It was negative 0.5 when we plugged in 2.5. When we plugged in a value like 4, x minus 3 was a positive 1. Let us analyze x minus 2. X minus 2 corresponds to the critical point of positive 2. To the right, picking any value that we wanted. When we plugged in 2.5 minus 2 gave us that positive 0.5 value. So here it's going to be positive. When we plugged in 4 minus 2, which was up here, was a positive value of 2. So it's going to be positive to the right of 2. Therefore, we can assume, and we know safely to the left, we can plug in points to test. To the left, x minus 2 is always going to be negative. So that is my sign analysis for these factors and this polynomial. So how did we determine the ultimate sign of our function? We have to multiply. So we're going to multiply these signs. So notice a negative times a negative gives me a positive. And notice our function was positive. In the second interval, we had a negative times a positive, and this gives me a negative. And notice our function is negative in the second interval. And then a positive times a positive gives me a ultimate positive. And notice to the right of 3, our function is positive. So a sign analysis can be used to determine whether or not your graph is above the x-axis or below the x-axis, which is synonymous with where is the graph positive or negative. So now answering these inequalities is very simple. X squared minus 5x plus 6, where is it? Less than 0 is the same thing as saying, where is this graph negative? And it's negative between 2 and 3, non-inclusive because of less than sign. So the sign analysis is a very strong technique. The first step will be to identify the zeros, arrange them in order, ascending on a number line, and then follow up with your factors and perform the sign analysis. In the next video, we're going to show another example of how to perform a sign analysis and not look at it graphically.